Hey there and welcome. Today, we're going to talk about the invisible force that powers pretty much everything you see around you. I mean, everything, from your phone to your car to the entire global power grid. We're talking about electromagnetism.
So let me ask you a question. What could your headphones, the magnet that holds your fridge door shut, and the vast continent-spanning power grid possibly have in common? It sounds like a strange riddle, right? But the answer is a single fundamental relationship that literally runs our world.
And that's it right there. They all rely on the hidden power of magnetism and its incredibly special relationship with electricity. You know, without our understanding of this link, our civilization would look completely different. No motors, no generators, no long-distance communication. It would all just stop. So let's break down how this whole thing works. Okay, so to really get this powerful connection, we have to start with one half of the puzzle. We've got to figure out what magnetism is in the first place. When you boil it all down, magnetism is about one thing: the electron. Specifically, it's the force that's created by the motion of electrons. Every single thing in the universe is affected by this force, but the way it shows up depends entirely on how those tiny electrons are organized. And that organization gives us three main flavors of magnetism. See, it's not just a simple on or off switch. It's more of a spectrum, going from super weak to incredibly strong. Let's quickly run through them. So first, you've got diamagnetism. In these materials, the electrons are all neatly paired up with opposite charges. Think of it like a perfectly balanced tug-of-war. They just cancel each other out. This makes these substances really stable, but also, well, not very magnetic at all. Then we have paramagnetism. Here, the electrons are kind of like a restless crowd, all pointing in random directions. They're not very organized. But if you bring an external magnetic field nearby, it's like a rock star walking on stage. Suddenly, they all snap to attention and the line. And for a moment, the material becomes magnetic. Believe it or not, oxygen is a great example of this. And finally, we have the one you're all familiar with: ferromagnetism. This is your classic fridge magnet. In materials like iron, the electrons are like a perfectly disciplined team. They all agree to point in the same direction, spontaneously, without any outside influence. And that amazing teamwork is what creates the strong, permanent magnetic fields we see every day. Okay, so we've established magnetism comes from moving electrons. Now think about it. Where else in our world do we see a ton of electrons moving in an organized way? That question is what led to the first massive breakthrough in this story.
An electric current. I mean, that's the literal definition of an electric current. It's just a whole river of electrons flowing through a wire. So if moving electrons make magnetism and a current is just moving electrons, then it stands to reason that an electric current has to create a magnetic field.
And this isn't just a theory. You can prove it with a really simple recipe. You take a wire, coil it up, wrap it around a piece of iron, and then run an electric current through that wire. And boom, you've just made an electromagnet. The second you turn the power off, the magnetic field vanishes. This was the first solid proof. You can use electricity to create magnetism.
Now that discovery was a total game changer, but it left a huge, tantalizing question hanging in the air. If electricity can create magnetism, could it possibly work the other way around? This is where a British scientist named Michael Faraday steps into the picture and changes, well, everything.
Faraday had this brilliant hypothesis. He figured that a changing magnetic field, and that word changing is the absolute key to all of this, could actually create or induce an electrical current in a wire, seemingly from nothing.
His experiment to prove it was genius in its simplicity. He took a simple iron ring and wrapped two completely separate coils of wire around it, on opposite sides. They weren't touching. One wire was hooked up to a battery, and the other was connected to a little meter that could detect an electric current.
And here's the magic. When he connected or disconnected the battery from that first wire, which created a change in its magnetic field, the meter on the second wire jumped. He had created a current in a totally separate wire just by changing a magnetic field nearby. It was an absolute aha moment for science. So what does this all mean? It means the distinction we make between electricity and magnetism, it's a false one. They aren't two separate things at all. They're just two different expressions of the same fundamental force, like two sides of the very same coin. Now, this discovery wasn't just some cool lab experiment. No way. This principle is the direct ancestor of the technology that makes our modern world possible.
It gave us the transformer. And the transformer is essentially just Faraday's iron ring experiment, perfected and put to work. It's a device that uses that exact principle, electromagnetic conduction, to change the voltage of an electric current. either stepping it up or stepping it down.
And why is that so incredibly important? Well, think about it. To send electricity across a country without losing most of it as wasted heat, you need super high voltage. But if you sent that same high voltage into your house, it would instantly fry your TV. So transformers are the miracle devices that step up the voltage for efficient long-distance travel and then step it down to safe levels right before it gets to your home.
So just how crucial are they? Get this, over 99%, that's basically all, of the electrical energy we use on this planet passes through at least one transformer, and probably more like a dozen, on its journey to you. They are the true unsung heroes of the modern age.
So let's bring this all home. That mystery we started with is solved. It turns out that electricity and magnetism were never two different forces to begin with. They are and always have been one single, unified, fundamental force of nature, electromagnetism.
And that's the force that's powering your screen right now. It's one of the 4 fundamental forces that write the rules for our entire universe. And it kind of makes you wonder, what incredible secrets are the other 3 just waiting for us to discover?